So we're continuing on now with our main sim, and to do that we need to build some constraints. So obviously we're going to separate the wheels from the bodies of the cars and set constraints between them. So we want the car to kind of rotate and bounce a little around. So to do that we'll need to unpack, and you know there's quite a lot of cars here, so it's going to be quite heavy. So I'm going to just grab a load of these, delete non-selected, and just you know, make a selection of a few just so that it runs a bit quicker. I'm gonna unpack these, okay, and transfer the class over. Okay, I want to keep that class attribute. I'm also going to need to promote that name attribute over. So here we've got the name, I think, on the points there. Okay, there's name here. So from points to primitive and the name attribute. Okay, so just putting that there. Okay, and now we're going to split the body. So just put a star on either side, and that will split the body like that. We could just use that in the group node of our angles, but just to be safe, we'll do it like this. I just prefer to use these splits so I can actually see that, you know, that this is working properly, just in case I make some kind of mistake. You know, we could just put this into the groups here, but then I wouldn't know if I'd made a mistake there. So in terms of the, you know, the results, there's no difference. So here in the body, I want to generate a new name attribute, right? So s at name is s at name. So I want to keep that name attribute plus I want body in this case, so that we know that this is the body of the car. And then to make them all unique, we use that class attribute I2A at class, and let's not forget semicolon, and to put a plus here. Oops. There we are. Okay, don't know why there's an error there. Seems to think that this is a float sometimes. Let's see. Yeah, you see, we're getting this implicit cast from float to integer, but the class is an integer attribute. I mean, if we come in here, let's see the name attribute. This needs to be on primitives, maybe that's why. So it's working. You know, we've got this name attribute, car 6, and then body, and then the class attribute there. There we go, it's gone now. It's probably because I had it on points, okay? And then for the wheels, pretty much same thing. Just drag this over, but change body to wheel. Okay, make a space there just to make it tidy. It won't leave a space there, as you can see. Okay, see, we get this error again. I don't know why. It's silly. Okay, and then we're going to merge these back together. There we go. And we're going to need a for each loop named primitive, and set this to class. Okay, and there we go. That will go over each car. Perfect. Oops, don't want to go over all of them. Okay, right to the top. And now let's start building our constraints. So RBD constraints from rules. So again, if you did the Renaissance project with a car, you know, we had kind of a bit more sophisticated setup of constraints. We had constraints between the wheel and the kind of the axle, so the wheel spinning around the axle, and then the wheels go up and down, and we had, you know, but in this case, I'm going to simplify it substantially, and we're just going to have one constraint in the middle, so all the wheels will be considered one piece. They won't be rolling, okay? The cars are kind of static, but we just want some roll, some bounce and roll between the wheels and the car, right? So constraints from rules from group to group, and we want so let's see the name. So body. So let's do body, star, and wheels. So star, wheels, star, like that should work for us. This is we need to change this, so because I'm kind of trying to do it to this, which is the name attribute, and we'd have to say add name is blah blah blah. We could do that, or we could just use those original groups, which were wheels, car wheels like that. Car, doesn't matter which way around they are, by the way, and the body, car body 6. So now to make sure that it grabs all of them, just do star there, star there. It's because there's a capital there, I think that's why. There we go. So now that'll give us a constraint between the two. If I drop a null here, we should see just the one constraint between the two, and that will work over all of our cars. Okay, because we're using the star thing there. Okay, let's drop a RBD constraint properties. Okay, connect that up on the side there, and the constraint, we want it to be soft. Okay, and drop the stiffness a bit. Let's try 6, and a bit less damping as well. Okay, you might want to play around with these values, just kind of isolate one car, do a couple of sims. It takes quite a long time, so these are values that I found worked for myself. But you can play around with this. So yeah, remember this. So this constraint is controlling how much this car can roll back and forward. Okay, so the stiffer it is, the less it's going to move side to side. Damping ratio is, so if you think about a spring, the first movement, if you kind of pull and pull a spring, then the first movement is the biggest, and then it kind of gradually goes down and down and down. So this damping ratio controls that. The more damping you have, the quicker that is. It's a bit like, you can think of it like air friction, but it's like the loss of energy over time. Okay, so we want to have a spring constraint like this. A soft constraint. I'm going to set it to just rotation because we're just going to be spinning around a point here. And then I also want another constraint, but in the same exact position. So I'm just going to pull over from the side here, drop a wrangle. Okay, because these are going to be two constraints in the same place. This will control just the spinning around, but I also need to keep this car in position there, keep them together. So for that, we'll use a, let me just make a group here, there's connectors. I don't think that matters actually, we just got the one constraint, but just in case, this needs to be on primitives and get that connectors group again. So this one is going to be a cone twist constraint. Constraint underscore name is cone twist. There we go. So a cone twist constraint is like a joint. Think of it like a joint. So if you ever done crowd simulations, ragdolls, then these are the constraints that we use for the joints, right? So you can control the degrees of movement around a point, basically. And then, so these two together will allow the car to, kind of rotate around this point in the middle within the boundaries of this and kind of within the springiness of the soft constraints, okay? So cone twist. The type as well is important. So s at constraint underscore type is all. Okay, So now we can just merge these back together. These two constraints. There we go, like that. And then we need to drop a facet. This probably is not necessary because we've only got the one constraint, but when you have constraints, you know, say if you have two constraints connected to the same point, then it's important to do this unique points. It's just a habit that I have of doing this process whenever I make constraints and when I'm using cone twists especially. So yeah, so that will just separate those points so they're not together. Then drop a primitive. Okay, and then do transforms and then just scale it down to 0. Oops, not -1, 0. And then you'll see we've still got our points, but they've just been squashed down into one location. We should be able to see them there. There they are. Okay, and then let's pack these together. Okay, so that we can get them both out of this for each block. So pack that, oops, there. Now, most likely we're going to want different results for the trucks, okay? So if you think about the values on the soft constraint for sure, they're going to be different for things like the vans and the trucks. So let me just, I think they were just 9 and 10 in terms of the name. So the transporter is the van and the truck is 10. So we'll give them this, you know, stiffer suspension basically. So if we come up here, drop a split. Before all of that, move this over. Oops. And we'll say at name. Oops. At name is car. Oh, we've changed the name attributes, haven't we? Let me just double check if we change the name on the points. Yeah, they're on the primitive, so if we just do, yeah, we can just do at name is car 9 star and at name is car 10 star because we've added to the end, so we'll need to put that in. Okay, and then to check that's working, maybe if we just color them, that'll be easiest way to do this. Okay, just give them a red color and then go like that. Alt click and drag. Okay, connect that up there. So for the stiffer cars, this will need to be on points, I think. There we go. Yeah, no, primitive, sorry. Our names are on the primitives now. We're going to stiffen these up, okay? So I'm going to double this to 12, and then the rest will be the same. And then we merge them together. At the end. Connect them to the end, and then run through everything. Okay, spacebar and F. There we go. So you can see the vans have come out red now, so that means, you know, they're coming this way. And these are the stiffer constraints. Perfect. Okay, so that's our constraints built and ready to go into our simulation.